An AI agent can help solve a lot of use cases nowadays. And we can see a lot of examples on the internet or in social media of how we can do it. But what happens when a certain use case or certain task has such a complexity that it demands that we work not just with one agent, but with a team of agents? So in this case, we will have what is called a multi-agent system, where in reality different types of agents will work together to achieve a more complex result. And today we are going to analyze 4 patterns of how we can design this teamwork between the agents. Let's go. Let's start with the orchestration pattern. So as the name suggests, this pattern means that we need to have an agent with the role of the orchestrator or the manager. So when should we use this pattern? The orchestrator pattern or the orchestration pattern should be used when we have a set of very distinct tasks that need to be done, but those tasks need to follow a certain logic. For example, if we have a task that needs to be broken down into smaller tasks that need specific knowledge, then we might have one agent that his only job initially is to analyze the content, the context of the task, and decides, okay, should I evoke or should I ask agent A to do what it needs to do? Should I ask B, C, or others? And a very important point in this task is that there is only one agent who decides the next steps. So this means that every time the orchestrator gives the task to some agent, after the agent completing that task, the result should go back to the orchestrator so that he can evaluate if the task was solved, if it is done, and what should be the next step. And in this next step, we can have calls to another agent, or he can decide to terminate the process. So you see that this concept of an orchestration means that we can have n calls to other agents to perform other tasks, or we can have a very simple process where he just calls one, evaluates the result, and stops. But this process should be always used when there is the need to have multidisciplinary tasks performed by different agents specifically trained for those tasks, but at the same time you need to have a node, a centralized node, to determine what is the next action. And this is the orchestration pattern. Next, we have the collaboration pattern. So this pattern is almost the opposite of the orchestration pattern, because in the orchestration you had one agent to be the orchestrator, to be the manager, but in here in the collaboration, every agent is independent, every agent decides on his own what to do, and there isn't a management agent. So the tasks are done by everyone, and then the information is gathered. There are different ways where you can implement this pattern, because you can have different number of agents in this collaboration network, and you can have also different iterations or more iterations. This is highly used when you want to do, for example, a research activity where you need to have an opinion or you need to have an outcome on different points of view. Imagine for yourself that you want to have research made on a specific topic, and you want to have results on different points of view. For example, a specialized person, an expert, you might want to have point of view of a user. You might want to have the point of view of the person who builds on that topic. So you can have these different roles. You can have different agents. And a bit like when we were in college and we would have like group works, right? When the teacher assigned us group activities, each one of us most of the times were responsible for doing a part of the task. And in here, it's also the same thing. So you have a group of agents that each one of them does his part, and then it's combined the work. And the way it is combined, it can have different variations, because you can design the system so that the outcome of all the agents goes to the same place. You can have, for example, in the end, a summarization activity from an agent to pick everything and put it into smaller words. Or, for example, each agent can do his job without the knowledge of the others, and then everything is simply added in the end. So there are different ways where you can aggregate the outcome of each agent. But the most important thing to take from this pattern is that there is no leader here. All agent, or every agent, belongs to a network, and each one does the task that he needs to do, and that's it. Then you can also have the router pattern. So this router pattern, it might seem at first glance that it is the same of the orchestration pattern, but in reality it's very different. Because the goal of the orchestration pattern was to bring a complex task into different agents, but then having an orchestrator deciding how to distribute the tasks. And it was always up for the orchestrator to decide the next step. Here in a router pattern, we have a router, and we have different types of agents specialized in a specific topic. But the router here, he is not a manager. He does not have the knowledge of the full process, and he does not lead the process to the following tasks. He simply redirects the task to a specific agent. So this means that there are two very big differences with the orchestration pattern. First, the router does not decide what should be the following steps after each iteration. He just does that one time. The information comes to him, and he is only trained, or he only has the experience based on the context to know to which agent he should redirect the information. At the same time, when the agent that was redirected with the information completes the task, the process flows with the rest of the requirements that are needed without going back to the router. So this means that the information doesn't go back to the router. He decides who to redirect, and that's it. His job is done. So this pattern is really useful when we have such a complexity in context variation of the information that it comes, meaning that we might have a scenario where we can receive very different sorts of information, and it is very difficult to have one agent specialized in all those topics. So what we do here is that we break the complexity and the variation of the different topics into specialized agents, and then we train one agent to simply give depending on the information. This is very similar, for example, in the office, when we have the office the office responsible person, the facility office, and whenever a client comes to the office, for example, the person asks, "Good morning, what are you doing here?" And the person says, "I have a meeting with Peter at 10, and then that person knows how to redirect the client to Peter. The router here doesn't need to have the knowledge of the reason why the client is meeting with Peter. He doesn't need to know the full details of the information, but he needs to know just enough to know that he needs to redirect to the agent A or B or C, and this is the router pattern. Finally, we have the pub-sub pattern, or the publish-subscriber pattern. And this pattern is not a pattern born from AI only. In fact, none of the patterns that we discussed here were born from the context of AI. They are patterns that exist already in complex processes, for example, in automation world. So this publish-subscriber, it is in fact somehow similar to the router in terms of use cases. So we have one agent called the publisher who is responsible to receive information and put the information somewhere in a queue or in a list. And then we have what it's called the subscribers, in this case the subscribe agents, that they fetch the information from that pile. So imagining is like having in your office, you would have like a common place where every information that it comes, a letter, something, it's put in that box, and then it is up for the employees to go there, see the information, and if it is of their respect, then they continue and do what it needs to be done. So if this pattern is really close to the router pattern, why do we need to have this? And there are basically a couple of reasons to do it so. First, the flexibility. So this pattern can bring a higher level of flexibility when designing the different agents. And the reason for that is that first, in this case, the publisher doesn't need to know which subscribers exist. In the case of the router pattern, the router had to have on his knowledge the different agents that could be redirected a certain part of information, right? So it means that if you would remove an agent or add new agents, you would have also to change the router for him to know about those new agents. In this case, what the publisher does is simply to grab information and put it somewhere available for everyone. So this means that in fact the publisher doesn't need to know what subscribers exist. He just needs to know how to summarize or organize the information that it comes in a certain way to be put it on that list. So you might even consider that for some simpler scenarios, you don't even need an AI agent to work as a publisher. But on other scenarios, you might want to have an AI agent to do some sort of an initial filter to define the type of information that it arrives so that the subscribers could already filter out what they need and what they don't need to process. But also the second reason is that the fact that we put the subscribers reading from that list, it means that it's not mandatory that the process flows to only one path, because in here you are giving the option for the subscribers to decide if they want to act upon the information or not. Because there is a message, put it somewhere, and if you have 3 subscribers, they might decide that the subscriber 1, this information is important for me, let me continue. The subscriber 2, yes, this information is also important for me, let me continue. But then the third may say, okay, this is not relevant for me, I will not do anything. So this brings a flexibility in terms of having multi-paths or multi-agents dealing with the same information. And when do you normally use this, or what is a good use case for this? Normally, when you have a certain task that triggers different processes across a certain organization, and those processes are completely independent, this can be a good pattern. For example, doing an employee on board. Imagine every time you hire an employee, you need to go to different systems, insert this employee, and you need also to trigger different processes, giving him a laptop, resisting him in the HR system, and so and so. Those processes are completely independent from each other. They don't care about each other, but they do care when a new employee comes. So in fact, you can have a process where that message of a new employee is put into a list, and all the information of the employee is in that message, and then you have all different types of systems that, if it is of their interest to resist something of a new employee, they will pick the message and they will continue what needs to be done. And this is the pub/sub pattern. So today we saw the example of 4 different patterns that we can implement when building a multi-agent system. And going a bit again into that part, remember that these situations are applicable when you have a task that has such complexity that it's not possible for one agent to do it, but you need a team of agents working together. And depending on the type of task, you can implement these different types of patterns. Thank you for watching for this video. Feel free to comment if there are more patterns that you would like to see, or if you have ideas for other videos. Thanks again. Hope you have a fine day. See you on the next video.